our last binary connective, the triple bar, will round out our connectives for our logic. We have one unary connective, the tilde, asserts negation, and 4 binary connectives, the dot, the wedge, the horseshoe, and now the triple bar. Now the triple bar here, it just symbolizes logical or definitional equivalence. It says both of these statements have the same truth value. They're either both true or they're both false. And so here are a couple of biconditionals that I think my dog Calvin lives by. Okay? A sock is good if and only if it's shredded. Right? So a sock is good, a sock is shredded. This statement is true when they are both true or they are both false. G, triple bar, S. I like to meet new dogs just in case I can sniff their bums. Right? Again, M, triple bar, B. They're either both true or they're both false. Now, in order for us to get a much more powerful logical language, we have to introduce a grammar. And by introducing this very simple grammar based on scope, it allows us to have a potentially infinite number of statements and arguments that we can formulate and evaluate in our logic. So it's very powerful, but it's also pretty simple. The basic idea of scope is simply this. We want to make sure, once we start having more and more logical connectives and simple statements, what each logical connective applies to. Right? And so, consider the following statements. Tilde P, well, tilde applies to whatever it's immediately to the left of. It's a unary connective. It applies to one thing. So, tilde applies to P. P dot Q, dot, that logical connectives in the middle of two simple statements. There's nothing else. So, it reaches out and connects P, reaches out and connects Q. It says both of these things are true. Same with S, triple bar, R. Two simple statements, logical connective in the middle of them. Triple bar reaches out and grabs S, reaches out and grabs R. It says these have the same truth value. However, once we start getting more complicated sentences with multiple logical connectives and multiple simple statements, then we have to have a mechanism for determining what simple statement gets attached to which logical connective. And so this statement, X horseshoe A dot T, that isn't a good sentence. It's not, as logicians say, a well-formed formula. It's ambiguous. It doesn't say anything that's either true or false definitively. And so we introduce a mechanism for disambiguating those sentences. And the mechanism is really simple. We just use parentheses, brackets, to indicate what logical connectives apply to what simple statements in what order. So if we took that simple statement, X horseshoe A dot T, and we disambiguated it here by putting our brackets here, right? That's like taking X horseshoe A, putting it in a lunch sack and closing it up. Now it's one thing. That horseshoe in there, it reaches out and grabs A, it reaches out and grabs X. It says if X, then A. That's one unit. Now when we go outside of that, we have that dot. The dot's a binary connective, so it reaches out and grabs T, and then it reaches out and grabs everything in the parentheses. So that conditional is true, and T is true. So notice this version of our sentence, T has to be true in order for this sentence to be true. We could disambiguate away this sentence another way. We can say X horseshoe, then put our brackets in around A dot T. Now, these are inside that lunch sack. It's sealed off. It's one thing. The dot reaches out and grabs T. It reaches out and grabs A. It says both of these things are true. When we go outside that, we have our conditional statement. If X is true, then, so our horseshoe reaches out and grabs X, then reaches out and grabs everything else here, right? A and T are true. Now notice, nothing actually has to be true in order for this relationship to hold. T has to be true for this to be true. This can hold even if none of these things are true. And so how we disambiguate our sentence using those parentheses, those brackets, that will determine what the sentence says. And similarly, imagine, right, if we didn't have this tilde here, we just had P.Q. That would say P is true and Q is true. But suppose that we had that tilde, but no brackets. Then we'd say not P is true and Q is true. Tilde P and Q. But if we want to deny the combination, we want to say it's not the case that both of them are true, then we have to put the brackets out here. Now we put these inside our little lunch sack. We sealed it off. It's one thing. Inside, the dot connects Q. The dot connects P. It says P and Q. And then outside of that, our tilde says it's not the case that everything here. It's not the case that both of these are true. Now, when we're translating from English into our formal language, we're trying to figure out, well, where do I put those brackets? Right? The best way to do that is to figure out what the sentence says. But there are other things that can help you at least. So punctuation marks, for example, commas and semicolons, things like that separate off clauses. That can help you determine what the scope is, where the parentheses should go. Other things like either or indicates disjunction, but either comes before the first disjunct or comes before the second disjunct, so you know where the scope is there. Both A and B. Again, that indicates the scope. We have these kinds of orthographic features that can help you disambiguate it, but ultimately you have to try at least to figure out what the speaker or author intended to say. What are the relationships that really matter? So let's go through one example in some detail. I'll give you a recommendation for how to do translations when you're starting off. What I suggest is that you break down translation into smaller tasks that don't overtax your working memory. So suppose we have this sentence: if Putin invades, then the United States will push for sanctions unless he withdraws. So the first thing we'll want to do, we want to take those capitalized letters. Those will give us our capital letters for our individual simple statements. We'll substitute in those capitalized letters for our simple statements. We'll leave in all of the punctuation and all of the logical form words. So we get, if I, for Putin invades, then the United States will push for sanctions, U, unless W, he withdraws. So now we've got our simple statements, we've got our logical form words. Next, we introduce connectives that correspond to those logical form words. So if then introduces a horseshoe, unless introduces a wedge. So now we get I, horseshoe, U, wedge, W. Now we have to disambiguate this sentence. There's more than one way it could be disambiguated, so we have to decide. And here again, if and then helps to indicate scope. If antecedent, then consequent, and our comma here as well. So we can use those cues as well as just thinking about the meaning of the sentence, and that will lead us to I, horseshoe, parentheses, U, wedge, W. Now, the final thing that I suggest you do is go back, reread your logical sentence to see if it captures the original. So you say, if Putin invades, then the United States will push for sanctions unless he withdraws. That is what this logical sentence seems to say.